Hi, hello, my dear friends. Welcome back to the channel. This is the sixth part of elbow leakage. I would recommend you guys to go to the previous videos to get better clarity. So, in the previous videos, I was talking about the strategies used in case of 4G wavelength system in order to tackle the elbow leakage problems. So that is using the null DC subcarrier in case of downlink and using off subcarrier shift in case of uplink. But what is the strategy used in case of 5G? There is no strategy used. That is what the 3GPP spec says. So for that, let me go through the 4G concept first. Let's say from the transmitter part, from the base station, I'm going to transmit the signal worth of 20 megahertz, right? So now this 20 megahertz will be centered around the DC frequency. So whether we want to transmit the data for a bandwidth of 10 megahertz or 5 megahertz or 3 megahertz, all of these things will be centered around the DC frequency. And hence, when the up conversion is done, the data will be centered around the carrier frequency. Now the thing is, at the UV side, let's say UV wants to operate at 5 megahertz, even though it is of less bandwidth. This bandwidth, the information will be placed in the center RBs, and it is transmitted. So the UV is expected to align with the base station's carrier bandwidth, the maximum bandwidth, which is 20 megahertz. So the UV has to perform the operations worth of 20 megahertz, even though it has got data only on 5 megahertz. So because of which this was not so flexible, and it was wasting a lot of resources. And the UV used the same the carrier bandwidth as that of the base station. There was no escape for removal of DC frequency, because the signal transmitted from the base station is this one, and after doing the down conversion we would get the equivalent baseband signal. In this case we will see that the DC is present, so that's why the different strategies were employed. But coming to 5G, there was a new concept introduced, that is called bandwidth part. Why is it introduced? Because in case of 5G, the wider bandwidths are used, like one is 100 megahertz, another one in another case it can go up to 400 megahertz. So let's say I will consider 100 megahertz for now. So this 100 megahertz in case of 5G at the base station will be the the carrier bandwidth, and this wider bandwidth will be operated at the base station. And now let's say there is an UV which wants to operate at 20 megahertz, and it has a data worth of 20 megahertz only. Then the base station can choose one of the bandwidth part for that particular UV. Let's say for now this is the bandwidth that is allocated to that particular UV worth of 20 megahertz. Okay, so if you clearly see, unlike 4G, this is not centered around the DC frequency. So when we do the up conversion of this, and when we do the down conversion, we are expected to receive the similar kind of for baseband signal at the receiver side, right? Now the thing is, since this is not centered around DC, the unwanted DC would be present at this point, and this will be clearly indicate that the DC is unwanted DC is not creating problem to the bandwidth at which the UV is operated. So there was no strategy required in this case to handle the unwanted DC in the uplink or downlink. All right, but now the thing is, there are some cases where the bandwidth part could be centered around DC, right? In this case, it is expected that the unwanted DC um, could present in the baseband signal, and in such scenarios it is expected that the information present at the DC would deteriorate. Okay, we have to live with it, and the thing is, we can leave to the fate of a decoder in order to identify those errors and correct them. All right, so I hope the things are clear. In the next video I will talk about the TX elbow leakage, and as well as I'll talk about DC offset concept. Please stay tuned. Thank you very much.